Okay, the exercise for question 9. Okay, for a function f, the Newton divided difference are given by table Q5 here. You have the x, okay, you got 3 data point, x equal to 0, 0.4, 0.7, okay, and the y naught, okay, unknown, y number 1 unknown, okay, the y number 2 is 6. So they, okay, because you're given these 2 data point, you can calculate f naught, okay, the, okay, f naught for the first Newton divided difference. Okay, and then so given, okay, the last 2 data point you can calculate is actually f1 at first level. Okay, the first level will be 6 minus let's say this unknown, okay, denote this is y naught, y1. Okay, put it here. The f1 level 1, okay, is actually f1 level 1 is actually 6 minus y1 divided by 0.4 minus 0.7 minus 0.4. Okay, this is f1 level 1. Okay, and then f0 level 1. Okay, level 1 is like you calculate the slope, y1 minus y0 divided by 0.4 minus 0. So it's the y1 minus y0 divided by 0.4 minus 0. Okay, so we don't know y1, we don't know y0. Okay, and okay, however, we know the f02. F02 is actually, you take, okay, mean this is a Newton divided difference. It look like the slope, okay, mean for your numerator is a, okay, dependent on the previous level Newton divided difference. So will be, okay, f11 minus f10. Okay, let me calculate here. In f02 will be your f1 1 minus f01. Okay, f02 denominator is 0 plus 2 is 2, so will be x number 2 minus x number 0. Because, okay, first time this one is x1 minus x0 without any gap. For second level, you have one gap, x2 minus x0. Okay, and then you know, okay, then you plug in f11 here. f11 is actually your y1 minus y0. Okay, 0.4 minus 0 is 0 0.4. f0, oh, plug in wrong. f11 is here, is 6 minus y1 divided 0.4 minus 0.7 minus 0.4, you have 0.3. So f01 is here, y1 minus y0, okay, 0.4 minus 0 is 0.4, okay, divided x2 is 0.7 minus 0, okay, 0.7 minus 0. Okay, simplify it because given, okay, f02 is actually equal to 50 over 7. Got two unknown.
The question Doctor copy less one data is the F11 equal to 10.
f11 equal to 10.
Yeah.
Okay, no wonder because two unknown, one only cannot solve. So f11 here, this one equal to 10. Okay, if equal to 10, then you can solve for y1. Then y1 plug in here, then you can solve for the y0. Okay, then you solve f11 first to, okay, to solve the y1. 6 minus y1 divide by 0.3. This is f11 equal to 10. Correct? Then 6 minus y1, 0.3 times 10, you have 3. Then you can solve for the y1. Okay, so y1 will be equal to 3. Okay, once you plug in y1, okay, f11 is 10, then straight away I plug in 10 here. Then you just plug in 10 because f11 given is 10. Okay, and then by solving f11 equal to 10, you know the value of y1 is actually 3. Then you plug in, this one is 3. Plug in this is equal to 3. Then you can solve for y nodes. So this is 0.7. So you have, okay, 10 times 0.4 minus, okay, expand everything, minus 3, because it's actually like this. Minus 3 minus minus is plus y naught. So divide by 0.4. Okay, this 0.7 you bring up, so 50 times 0.7 divide by 7. Then you can solve for your,
Doctor,
yes.
how to know F11 is equal to 10?
Just now you said the question there, because I copy missing.
Yeah, the original question in book lah got that value. I found one equal to 10.
Missing. Hold on. Yes. Okay, I think, okay, when we now, so the exercise that I gave to you, I think cause missing, cause this one f1 1 equal to 10. Okay, the exercise 4 that I generated from this one, okay, this version is actually missing this data. So f11 equal to 10. If not provide this one, we cannot solve. If just now, if f11 value not provide, I got the y1, I got y naught, and only one value here, two unknown, they have one equation cannot be solved. So this one is missing this value. Okay, so now, so from f11, you can solve for y1. f11 equal to 10, then you can solve for y1, which is 6 minus y1 divided by 0.4 minus, okay, 0.7 minus 0.4. Okay, then you can solve for y1, okay, which is y1 equal to 3. And then f02 is actually, okay, f11, which is 10 minus f01. Okay, f01 is actually y1, which is 3. So 3 minus y naught, 3 minus y naught, okay, divided by 0.4 minus 0, which is 0.4. Okay, now, okay, and f02 given the equation is equal to 50 over 7. So now you have one unknown, okay, from one equation you can solve for your y nodes. Okay, I just, okay, make it this one to make it as a one fraction. So 10 times 0.4 I have divided by 0.4. So same denominator, I can combine these two terms. So here, so be careful, this is a, okay, the whole term bracket, so minus minus, this is plus. Then 0.4 0.7 minus 0, it bring to right hand side, become time 0.7. Okay, now you can solve for the y nodes. 10 times 0.4, you have 4 minus 3 plus y naught. Okay, and then you can have some more, is 50 times 0.7 divide 7 times 0.4. So 4 minus 3 is 1. So mean the y naught is actually, okay, 50 times, okay, or you want to cancel this one. This become 0 0.1. 50 times 0.1 times 0.4. Okay, 4 minus 3 is 1. So bring to right hand side minus 1. Okay, 50 times 0.1, you have actually, this one is 5 times 0.4 minus 1. So this is actually 2. minus 1. Y naught is 1. Okay, so you check it, the answer, number 9. Hmm, 9 or 10? Number 9. Okay, fx naught is 1, fx1 is 3, y1 is 3. Okay, and then y naught is 1. And copy this thing. Ff naught, okay, this is actually y naught. This equal to y naught. Fx1, this is equal to y1. So this is correct. This is correct. Okay, f01 equal to 5. Do we calculate f01? Oh, we didn't. Okay, go to calc. What else they want? Determine the missing entry. So y naught, y1, and then we need to calculate f01. Okay, the y naught that you obtain, y naught is, okay, 1 and 3. So this value is 1, this is 3. Then you can calculate f01. Okay, 1 minus 3, divide 0.4 minus 0. So you have, okay, 1 minus 3, negative 2, divide by 0.4. Okay, you may just calculate it. Negative 2 divide 0.4. So negative 5.
Doctor, is 3 minus 1,
Hmm?
right?
Positive. Positive 5. Go on.
X, Y, Y1 is 3. So Y1, 3
Y1
minus
is 3. Oh, reverse. No wonder. Okay, thank you. These two value reverse. Y1 is 3. Y naught is 1. Reverse. So it's 3 minus 1. So positive. 3 minus 1. So positive 2. So positive 5. So the answer correct. So A, determine the missing entry. Your determines your Y naught, Y1, F01. And then question B, determine the value of F 0.25. Okay, F 0.25. Okay, so now with all the Y naught, Y1 and this value, this is 5. You can conducted your Newton divided difference table, and then you can plug in X is 0.5 to estimate your F 0.25. Okay, we can quickly perform it using Excel. Where's my Excel? You have the X here, 0, 0.4, 0.7. Okay, and this is the Y is, this is 1, this is 3, this is 6. Correct. 136. This is 510. Okay, 510. This value is equal to 50 over 7. Okay, this is a first level. I just put Fs. Okay, first level Newton divided difference. This one is the second level Newton divided difference. like this, right? 50 over 7. 1, 3, 6, 5, 10, 50 over 7. Okay, now you want to estimate actually f 0.25. Mean the f, okay, 0.25. Okay, first of all, you look at f 0.25 is actually inside the list. So this is interpolation. If outside, maybe you still can use, but it's not accurate. If the y they are going to estimate, but the x value is outside of the list, so it's not accurate lah. So f 0.25, okay, when you use Newton divided difference is actually mean approximately equal to this is 3 data point is actually you have the p2x, okay, and the p2x is actually equal to your f00, which is this is 0 level, which is f0 f00 is here, this cell. Okay, f00 is here. This is a f01. This value is f02. So 0 level, and then the f01 first level multiplied by x minus x naught. Okay, second level f02, okay, multiplied by x at two term, x minus x naught, and then x minus x number 1. Okay, now I will quickly calculate it using Excel. Okay, will be more faster. f00, the value is actually 1, okay, plus f01, this value, multiply, okay, the x that we are going to estimate is 0.25, so minus, this is the x naught, click the cell of x naught, okay, plus f02 is this value, then multiply, okay, 0.25 minus x naught time 0.25 minus x number 1. So f 0.25 that you estimate using Newton divided difference is 1.98214. Checking here, 1.982. This is using 3 decimal place. So this is question B. Determine the value of f 0.25. So B, okay? Is it okay?
Okay, doctor.
And then, your friend Simon claims that the above data can be used to estimate f 0.25. Then, are you agree? Okay, are you agree with him? Justify your answer. Okay, Dayang, can you use to estimate f 0.85? Similar view, estimate f 0.25 or not? Okay, Dayang, are you around?
Yes, doctor.
Yeah, can you use this table question 9 to estimate f 0.25 as what we did for f 0.25? Can or not?
Can we go back to the 0.25 again? The
Oh,
one
you
that
don't need
you
to go
did.
back to 0.25. If you
Um,
understand the concept of interpolation, then you will straight away know can or cannot.
then we can.
Can answer can or cannot?
Can.
Okay, the rest please. Okay,
Someone just
Cannot.
said cannot.
yes, cannot. Already mentioned
It's
from the
over 0.7.
yes, from the beginning of
Oh,
the class. We already mentioned what is the meaning of interpolation. Even though just now we solved the question, also we said make sure the f that you are going to estimate, the x value must be inside the list. Inter. So this one it cannot. The answer is cannot. The reason is 0.85 is outside of the range 0 to 0.7, so cannot.
Okay, doctor.
So this is question 9, exercise 4.